Okay, I'm going to start with multiplying and dividing fractions rather than adding and subtracting, only because this is actually easier to do than to add and subtract, and I'll talk about that more later. Okay, so if you want to simplify a fraction, so you have 10/15, and if you want to simplify that to its lowest terms, you're going to hear this a lot, reduce to lowest terms, then what you want to do is look for a common factor. And I could rewrite 10 as 5 times 2, and I could rewrite 15 as 5 times 3. You are allowed to reduce common factors. Notice how the numerator has a 5 and the denominator has a 5 in common. And if you were to divide 5 by 5, you get 1. So the 5's here actually mark out or create 1. And what you're left with is a 2 on top and a 3 on bottom. So 10/15 reduces to its lowest terms of 2/3. So we just simplified 10/15 to 2/3. Okay, the process works the same for negative numbers. So if I have negative 18/24, notice that negative sign was off to the side before. I've just put it on top. As long as I only have one negative sign, then I can place that negative sign anywhere I want. I'll get more to that later. But so right here, I could reduce 18 to its common factors. Now, if you want to create a factor tree, that's fine. And so you could rewrite negative 18 as negative 2 times 3 times 3. And 24 we could write as 2 times 12, and then I can reduce 12, 2 times 6, 2 times 3. So 24 I can write as 2 times 2 times 2 times 3. And remember earlier I said that you could mark out common factors. So this 2 and this 2 are common factors. Notice that negative sign hasn't gone anywhere. And then the other common factors are this 3 with this 3. You have to reduce top and bottom, not left and right. And so what do I have left? On the top, I have this negative sign, and I've got a 3 left over. So I have negative 3 on top. And on the bottom, I have 2 and 2, which is 4. So negative 18/24 reduces or simplifies to be negative 3/4. Another way to work this problem is like this. You can see that they have a common factor of 6, and what you do to the top, you have to do the exact same thing to the bottom. So if I divide by 6 on top, I have to divide by 6 on bottom. And so negative 18 divided by 6 is negative 3. 24 divided by 6 is 4. Eventually, this right here will be the method that you use, but until you can see what their common factor is, you may want to stick with this method here. Okay, so for this problem right here, we can really start out doing the same thing that we did before. The long way, I feel like, is creating your prime factorization like this. So this becomes, the numerator becomes 2 times 2 times 2 times 7. The denominator becomes so there's 5 of those 2's. 2 times 2 times 2 times 2 times 2. And so now we start marking out the like factors. This and this are the same, this and this are the same, this and this are the same. And so now what I'm left with is I'm left with negative 7 on the top, and I've got 4 on the bottom. So negative 56/32 reduces or simplifies to be negative 7/4. A much quicker way to do this problem is you can see that they both have 8 in common. So I would divide the top by 8, I would divide the bottom by 8. Remember, what you do to the top, you have to do the same thing to the bottom. So this becomes negative 7/4. Much quicker this way. But again, if you're having a tough time seeing what to divide by right here, then maybe you should stick with the top method until it comes to you a little more naturally. Okay, so this problem right here, what I would do is I would do my factor tree again. Okay, so this becomes 5 times 42, then I've got 7 times 6, 2 times 3. Now I've got all the primes for the numerator. So 210 becomes 2 times 3 times 5 times 7. And the denominator becomes 385. Let's see here. I know 5 will go in there. Looks like 77 times, and then I've got 7 times 11. So the denominator becomes 5 times 7 times 11. And so we, again, going to mark out the like factors. 5 comes out, 7 comes out, and so what I'm left with on top is 2 times 3. So I get that from there and there, which is 6. And then on the bottom, all I have left is an 11. So 6/11 is what this reduces to be. I think this one would be a lot harder to do by seeing that 35 is your common factor. That would be hard for me to see as well. So probably what I would do if I had this problem and I were hoping to do it a little bit quicker than doing the factor tree, is I would divide top by 5 and the bottom by 5, and I would see that that I get, let's see here, that's 42 on top, and then I get 77 on bottom, and then I can actually see that, oh wait, they both have a 7 in common as well, so I'm going to divide by 7 there. So this one I actually, like in my head, I reduced twice. 42 divided by 7 is 6, 77 divided by 7 is 11. So I get the same answer, but notice I had to reduce twice. And if you think about it, did I reduce by 35? Yeah, I really did. So I could not have seen that 35 was their common factor without actually sitting there and doing some thinking about that. So it doesn't hurt to have to reduce a couple of times, or even more than that. Sometimes you can't see that they have a 4 in common, and so you reduce by 2, and then you see that they're both still even, and oh, they can reduce by 2 again. So sometimes I've had to reduce more than once as well. But the factor tree works every time as well, but you just have to make sure you have the correct factors. Okay, on a problem like this, what the top means, that 5xy, that means 5 times x times y, and the bottom means 3 times 5 times x. And remember, I've been saying all along, you're allowed to mark out common factors. Well, they have the 5 in common, correct? And then they also have the x in common. So what you're left with on top is you're left with just plain old y, and then 3 in the denominator. So that's what you're left with. Okay, to multiply fractions, this is actually a lot easier than adding fractions, but to multiply fractions, you just simply multiply straight across. So I would do 3 times 1, and I get 3, and then I do 4 times 5, and I get 20. And then don't forget to ask yourself if it is simplified. Do 3 and 20 have any other common factors that you could mark out? And they don't, so 3/20 is your final answer here. Okay, so for this problem, you've got -5/8 times -2/3. Now, there's a couple of ways to work this problem. We could just multiply straight across and then reduce, or if you want to look at this as, oh, look at that, the 2 and the 8 have something in common, so you are allowed to reduce diagonally or up and down, but never left and right. What I mean by that is I can look at this right here and see if the 2 and the 3 have anything in common, and they don't. Or I could look at the diagonals and see if they have anything in common, and they do. So I could mark out the 2 and the 8 have a 2 in common, so you want to divide both by 2. This becomes 1, this becomes 4. Don't forget your negatives in this problem. So really I have -5 times negative 1, which is positive 5, and then 4 times 3 is 12. And then always ask yourself, do 5 and 12 have any common factors? And they do not. So 5/12 is your final answer here. Okay, so for this problem, I've got negative 14/15 times 20/21. And I'm going to look diagonally because I can see that the 15 and the 20 have a 5 in common. So I'm going to divide both of those by 5. So whenever I divide 15 by 5, I get 3. And whenever I divide 20 by 5, I get 4. Now, look at your other diagonals, 14 and 21. They have a 7 in common. So I'm going to divide 14 by 7 and I get 2. I'm going to divide 21 by 7 and I get 3. You cannot reduce left and right, only up and down or diagonally. So I can't reduce anything else. But don't forget, we do have a negative in this problem. So this becomes negative 2. So what is negative 2 times 4? That's negative 8. And then I've got 3 times 3 on the bottom, and that's 9. And you probably need to practice doing this on your calculators as well. So type in negative 14/15 times 20/21 and see what you get. Okay, so a problem like this, multiplying 1/7 times 56, what you need to realize is that 56 can be written as a fraction if you place it over 1. 56 over 1 is the same thing as 56. And when you multiply by 1/7, do you see that they have a common factor of 7 involved here? So I could divide the 7 by 7 and I get 1. I could divide the 56 by 7 and I get 8. Now if I multiply straight across, 1 times 8 is 8. 1 times 1 is 1. So 8 over 1 is the same thing as just 8. Incidentally, multiplying by 1/7 is the same thing as dividing by 7. So 56 divided by 7 is 8. Okay, so let's look at the next part. 12/5 times negative 20x, and remember I can place that over 1. So can I reduce anything? Well, it looks like I can reduce the 5 and the 20. So 5 divided by 5 is 1, 20 divided by 5 is 4. And so now I can just multiply straight across. 12 times, don't forget your negative, 4. 12 times negative 4 is negative 48. I had an x up there too, I can't forget that. And then 1 times 1 is 1. So this right here reduces to be negative 48x. Okay, anytime you deal with fractions, you have to understand the word reciprocal. The reciprocal of any fraction is just flipping it over. The bottom goes to the top goes to the bottom. And you can't have zeros anywhere in the fraction, as in you can't have 0 on the top, you can't have 0 on the bottom. So if you ever want to know if something is a reciprocal, just multiply the two together. You should always get positive 1 as an answer. So if I wanted to find the reciprocal of 2/3, the reciprocal is simply going to be 3 over 2. And if you want to know for sure if they are reciprocals, just multiply them. 2/3 times 3 over 2. The 2's reduce each other, the 3's reduce each other. You're left with 1's everywhere. And 1 times 1 is 1. What about a whole number though? What if I had, let's say, 5? So if I have 5, what is the reciprocal of 5? Well, remember I told you earlier that 5 is the same thing as 5 over 1. So its reciprocal is 1/5. Okay? So if you were to multiply those, you should get 1. Okay, on each of these, we're just finding the reciprocal. So the reciprocal of 4/9 is 9/4. Just flip it over. With a negative number here on part B, you simply keep the negative sign with it. So what is the reciprocal of negative 1/6? It is, flip it over, just swap these two, And keep your negative sign. So the reciprocal is negative 6 over 1, which is also negative 6. The reciprocal of negative 14/5 is just 5/14. And this reciprocal of 7, remember this is 7 over 1, so the reciprocal of 7 is 1/7. Okay, I really like this chart because it kind of gives you a visual of the different meanings of these words. If I want the opposite of negative 3/8, opposite of a number is one of them is positive, one of them is negative, but they are the same number, one's positive, one's negative. So the opposite of negative 3/8 is positive 3/8. The absolute value of negative 3/8 is asking you what is the distance that negative 3/8 is from 0. So that answer is also 3/8. The reciprocal just means flip it over, but keep that sign, and always go back to your original number back here. So I'm going to keep the negative, but I'm going to flip it over. Okay, so let's look at 1/2. The opposite of 1/2 is negative 1/2. The absolute value of 1/2 is, how far is 1/2 from 0? It is just 1/2 units. And the reciprocal of 1/2, just flip it over. So it's 2 over 1, which is the same thing as 2. Okay, so let's look at 9/5. The opposite of 9/5 is negative 9/5. The absolute value of 9/5 is how far 9/5 is from 0, and that is just 9/5. And the reciprocal of 9/5 is 5/9. Just flip it over. Okay, so let's take a look at negative 5. What is the opposite of negative 5? It is positive 5. What is the absolute value of negative 5? It's asking you how far negative 5 is from 0. It is 5 units away from 0. And if I want to find the reciprocal of negative 5, I keep the negative and I flip it over. Okay, you may want to hit pause here and study this because these words come up a lot: opposite, absolute value, and reciprocal. So you might want to pause and take a look. Okay, so this page is talking about fraction division. And the rule for fraction division is you keep your first one, you change your sign to multiplication, but you have to multiply by the reciprocal. So let's look at the next page and I'll show you what I mean here. So I have 2/5 divided by negative 3/7. The rule is keep your first one the same, do not change it. Change your sign to multiplication, but flip or give the reciprocal of the second one. And then you just multiply straight across. You can reduce if there's any possibility of reducing. I don't see any common factors, so we're just going to go ahead and multiply straight across. 2 times negative 7 is negative 14. 5 times 3 is 15. Okay, here's the thing though. If you're using a calculator, do not keep, change, flip. Just type in exactly what you read. Do not be changing your sign. Do not flip your second fraction. Just leave it. Let the calculator do that work for you. The only time you need to keep, change, and flip is whenever you are doing this by hand. Okay, so let's look at this one. So again, 2/3 divided by n over 5. According to fraction division, you keep the first one, you change your sign to multiplication, and you flip your second one. And now you just multiply straight across. 2 times 5 is 10. 3 times n is 3n. And there's nothing else we can reduce there, so 10 over 3n, or 10/3 is the answer. Okay, for this problem right here, we're going to be looking at negative 3/4 divided by negative 7/8. Remember, in fraction division, you keep your first one. Didn't change that at all. I do change my sign to multiplication, and I flip-flop my second one. Notice I kept the negative sign. Now I'm going to multiply straight across, or if you can see that there's something that can be reduced, we could do that. I can see that the 4 and the 8 have a common 4. So now I'm just going to multiply straight across. Negative 3 times negative 2 is positive 6. 1 times 7 is 7. 6/7 is my answer to this problem. Okay, 7/18 divided by 14/27. Remember, keep your first one, change your sign to multiplication, and flip your second one. So the 7 and the 14, they have a 7 in common, right? So I divided both of those by 7. The 18 and 27, they have, what, a 9 in common? So 9 will go into 18 twice. 9 will go into 27 3 times. And now I can multiply straight across. 1 times 3 is 3. 2 times 2 is 4.